So today we are going to solve find k pairs with the smallest sum. This is LeetCode 373, and in this question we are provided with two arrays, that is num1 and num2, and these arrays are in sorted ascending order, and an integer k is also provided. So we have to define a pair, that is u and v, where u will be from num1 and v will be from num2, and we have to return k pairs such that those k pairs must have the smallest sum. So as we can see in this example, nums1 is 1 7 11, nums2 is 2 4 6, k is equivalent to 3, and output we are having 1 2 1 4 and 1 6. This is the 1 is from num1 and 2 4 6 are from num2, and these were having the smallest sum. So how we can solve this question? Let's see. So the first approach that I can think of, and this is definitely not an optimal solution, but what are we asked for? First thing is the pairs, right? So if we say that nums1 is of length m and nums2 is of length n, then we know that for each and every m we have to go through this whole n and create pairs, right? So firstly we will be creating pairs and calculating the sum. So this whole procedure will take time of big O of m dot n, right? This will take time, sums will take this much time, sum of all the pairs will take this much time. Now after getting the sum of all the pairs, we want to sort them, right? Because we want the smallest k pairs. So we will sort the whole sum list. Suppose it's a list. So it will take how much time? It will take mn log of mn, right? And after that, what we will do, from that sorted list, we will return the top k elements, and that will be our resultant. So how much time this whole algorithm will take? So this whole algorithm will take about mn log mn time, and we know that this much time complexity is most likely to exceed the time limit, and we will be having time limit constraint and we won't be able to pass all the test cases. So we know that we are not able to proceed with this approach. So let's try to find a more optimal approach. One thing that is already provided in this question and we hadn't utilized that is that our arrays are in sorted order. So if our arrays are in sorted order, how we can utilize this characteristic? What we can do is, first thing that we all know is, if we are going to make a pair of the very first elements of both the arrays, then we will be having the smallest sum pair, right? We are sure about it. So this is the first thing. Now after taking these two elements, what can be the second most smallest pair? Either it will be this or this, in the sense the first element of nums1 and second element of nums2, or first element of nums2 and second element of nums1. So that is, if we are saying in the first case I and j 0 0 are the indexes of the smallest pair, are the elements which will result in the smallest sum, then what will be the next smallest case? That can be I j plus 1 or I plus 1j, right? This can be the possible solution, possible pairs, this and this. So we know that every time the pair that we are taking as the smallest, next time we have to check these two conditions. We said fine, we will be checking, and this is how we will be proceeding and traversing both the arrays, and we will be returning k values, right? Oh, here you are not able to see the value of k, right? Let me me just slide it here. Okay. So now we know that we need to return 3 pairs. We said fine, we will be using this whole approach. So how we are going to keep check of the smallest pair? Now we know that we have to check ij plus 1 and I plus 1 j, depending on that j plus 1 and I plus 1 should be less than m or n, where m is the length of nums 1 and n is the length of nums 2. Then only we can check, because if ij plus 1 is out of the bound, then we won't be having an element, right? So these two values, every time we will be checking, they are inbound. And how we are going to keep check of the smallest pair, because these two pairs are there, but how we are going to know that this is the smallest one? So for that we can use a data structure, and that is heap, right? We can use min heap. So using min heap, we will be storing these sum and indexes, and we will be having what? The minimum sum whenever we are going to pop a value from this heap. So in that way, our rest of the pairs will also be stored, and we will always be having the minimum one at the first place so that we can pop it. So that's why we will be using minimum heap. Now we are clear that we will be using minimum heap and what ideology we have to use to solve this whole solution. So let's now go through the dry run and see how we can solve this whole question with this ideology or approach. So now let's consider, for now our queue is empty, right? This is our queue. Now as we discussed that we know that the very first elements of both the arrays are always going to sum up as the smallest sum, because the arrays are sorted. So we will insert this first value in our queue. We said fine, and also just define an answer array, right? Because in this we will be storing our answer. So in queue, what we are going to do, we are going to store the sum firstly. So 1 plus 2 is 3, and the indexes, that is 0, 0. Okay. Now what we are saying, now we have to check all the rest of the values, right? So what we are going to do, firstly we will pop this value. So what we will get, as we know right now it's the only value, so we will get these I and j. And what we are going to do, we are going to add the I and jth element in our answer, right? So we will pop this and we will insert in our answer array. What we are going to insert? We are going to insert the elements, that is 1 and 2. Same time we are having I and j when we pop the values, right? We got the I equals to 0 and j equals to 0. So now what we are going to do, we are going to insert in our queue those two conditions that we just said. The next most smallest sum pair will be I j plus 1, j I plus 1. So we will check I j plus 1, that is 1 and 4. So we know that j is right now inbound and I is 0. So what we can do, we can sum up the values, that is 5, and then what we can do, we can check for j, and we are going to sum up the values and store the index, that is 0 and 1. After that we are going to check for j and I plus 1, that is 2 and 7. So it will become 9 and indexes will be 1 and 0. So this is our current status of heap queue. Now again we will pop our value. The minimum value will come out, that is this one. Again we will get I equals to 0 and j equals to 1, and we will insert it in our answer, that is it will become 1 comma 2 and I0 is 1 and J1 is 4. So this will be our current status of answer array. Now we do have I equals to 0 and j equals to 1. So again we will do the same thing. We will insert values in our queue. So again, what will be the values? Values will be I and j plus 1. So I is again 0 and j plus 1 is 6, right? And it is still inbound. J plus 1 index is equivalent to 2 and it's inbound. So we can take the value. So 1 plus 6 is 7 and indexes are 0 and 2. This is one value. Then what is the second value? Second value will be I plus 1 j. I plus 1 is 7. 7 plus 4. So that will be 11. So 11 and index will be 1 and 1. So this will be another value. And we already know that previously 910 was already existing. So it is there. Right now this is not the manner in which our queue will be looking. Why I'm saying like this? Because queue is always having insertion and deletion in big O of log n time. Why it takes this much time? Because it maintains the minimum value. So in that manner it inserts and deletes. So that's the reason when we are going to insert this value now, this will come after this value 9 sum, because this pair is having the largest sum, that's why. So just remember, this is not in sorted order, but it will be in sorted order when we are going to code it up and we'll be using heap queue. Right now, just for understanding, we have wrote it in this manner. Now again, what we are going to do, we are again going to pop the minimum value. So this is our minimum value. We are again going to pop it. Again we will be having our I equals to 0, j equals to 2, and we know that we have to insert these value into the answer, right? And our answer will become 1 comma 2, 1 comma 4 and 1 comma 6. I know we are running out of space, but just bear with me. So we know that our answer list is now of length 3, that is k. So we don't have to proceed and we can return our answer. So this is how the whole procedure is going to work. Firstly, we will be creating queue and our answer array. Then we are going to insert the very first elements of both the arrays and going to create a pair of it. And then we are going to check for I j plus 1 and j I plus 1, and again we have to continue doing this until we have ended up our arrays or ended up our queue and k is greater than 0, or our answer array is not equivalent to the length of k. So this was the whole solution. So what is the time complexity of this whole solution? Let's see. So we know that for getting all the pairs in best case, we will take big O of k time, right? Big O of k time. But in worst case, it can exceed up to big O of m cross n time, right? This much time will be taken by pairs. And after that, we are inserting and popping out the values from queue, minimum heap. So it will also take how much time? Big O of log k to big O of log mn, right? So we know that for these values we will be taking this much time for insertion. So that's why the whole time complexity will be from k log k to mn log of mn. So this is the best case time complexity, this is the worst case time complexity. And for space, now for space complexity, what we are doing is let me just change the color because we are already having very less space. So just I want to let you all know how much space complexity we will be using. So for Q as well, the space complexity can be from K to M cross N length. Our Q length can exceed from K to Mn. But there is one more thing that we need to create that we hadn't discussed in this question. So if you see this example, the last one, I equals to 0 and j equals to 2. If suppose our k is not equal to 3 and it is equivalent to 4, if our k is not equivalent to 3, it is equivalent to 4. So we will be proceeding from this step. So what will be the next step? Next step will be I and j plus 1, right? But we can't do that. So what we will be doing, I plus 1j, right? That is 1 comma 2. 1 comma 2 will be this one, 7 and 6. But possibility is sometimes these values are also going to be repeated. Suppose in next step if we are doing 1 1 again, so this same value will be inserted again. So how we can keep check of that and reduce this repetition values, this repetitive work? So for that we need to keep a visited set. So it will also take some space. So we will be keeping a visited set in which we will be storing the indexes for which we already have inserted the sum, so that we don't have to repeat our work. So in this case our total time complexity will be this value and our space complexity will be this value k or mn. Both visited can also extend up to m cross n because we are inserting two values in it. Now let's go and try to code this whole solution. I know this whole screen is looking really messy, but I hope the whole explanation was clear to you all. So very first thing is we have to add our import for heap, that is heap push and heap pop. Got it. Now as we discussed, m is length of nums 1 and n is length of nums 2, so that we know we are in bound. For that reason we are using it. Now we have to define our answer, which is an empty list, and our visited set, which will keep check of all the indexes so that we won't be repeating the indexes in our answer array or our queue. So now we have to use min heap, that is going to be equal, as we discussed, that we will be storing the very first values from both the arrays, right? So that is 1 and 2. So how we are going to store? We will be storing the sum, that is the nums 1 0 plus nums 2 0, and these are in, so this is our tuple, and next thing is the indexes. So 0 0 is the index. Got it. Then we know that in visited set as well we need to add this as it is in our queue, so we will add it in our visited set, right? Now what we have to do, we have to run a loop where we will be checking our k, which should be greater than 0, and our min heap. If we ran out of any one of these conditions, then we will step out of this loop. So firstly we will pop the value I comma j. So we do heap pop from our min heap, and now what we have to do, we have to append first in the answer that we were doing in the dry run, I and nums2 of j. I am forgetting 1 and 2, and then we will be having a error while running. So second thing what we were saying is I plus 1 should be less than m, and I plus 1 j should not be in our visited, not in visited. Then only we will proceed and we will do this thing. What? Heap push. What is wrong with me? Heap push and min heap nums2 j and nums, and these are the indexes, that is I plus 1 comma j, right? Now we have to add this whole thing in visited as well, visited set. So it will go something like this, I plus 1 and j. Now we will do same thing for I and j plus 1. So if j plus 1 is less than n, and again we will check the existence of it in our visited set, right? I comma j plus 1 not in visited. Then what we are saying? We are saying just do this thing. Do same thing but with these indexes, that is nums of I and j plus 1, again j plus 1, then j plus 1. That's it. No, because we are also keeping check of k, so we have to reduce it, and at the end we will return our answer. So this was the whole code. Now let's check whether it's working or not, or I had done something wrong. So I had done something wrong, that is min heap. Okay, that is capital H. So now it's working and we can see that it's quite efficient. So I hope this video was helpful, and if you find this video explanation helpful, then you can like this video, subscribe my channel, and soon I will come up with some other questions. So thanks for watching.